health of either environment or human body, or animals and other entities in the environment. And finally, the time, the exposure time, that is very important between the host and also the actually antigen, that is pollutant or xenobiotic. These are the three important factors we try to learn yesterday, right? Toxicity, tonnage, and time. Now today, let us proceed with the next concept, and the next concept is about the atmosphere. This is a very important aspect. Much of the unseen drama happens in the atmosphere. Now, by the way, what is atmosphere? Atmosphere is nothing but blanket of air filled space that is above the ground level. What is present under the ground level also is a big activities, but let us not for present sake bother about it. But we try to understand what is this atmosphere, what is its structure, how this structure plays important significance in distributing and also kind of exerting a influence on the pollutants that we generate at the ground level because of our anthropogenic human activities. This structure is very unique and peculiar. We have to remember this, and it is from the ground level as you go up, that is longitudinally high towards the sky, you will get all kind of layers, like what you get layers inside the earth and inside the ocean. Similarly, we have some layers which are very much defined, called troposphere, stratosphere, mesosphere, and ionosphere. Tropo, very near to ground. Meso, above tropo. Then strato, above tropo, and above strato you have mesosphere, and at the final last layer, highest layer, is called thermosphere or ionosphere. There is a differential height, differential distance between these four layers, and we learn about it. If you say take ground level as 0 kilometers and up to 0 to 8, that is 8 kilometers, we call it as what is called ground level atmosphere, which is generally does not have name, but generally it is because Homo sapiens, that is human beings, live on the ground. It is also known as homosphere. 0 to 55 kilometers from the ground level is known as homosphere. It is a part of the troposphere, that is the first level in the atmosphere. Extremely important. In fact, we are more concerned about this particular layer, that is 0 to 55, and particularly 8 to 10 kilometers above the ground level is what is more important, because that is where clouds, rain, and everything comes. Even the aeroplanes run around in this particular region, about 8 to 10 kilometers. So it is extremely important that this particular blanket of air should not be polluted, since the air currents and air exchanges happen within this layer, and much of the air we breathe, that is terrestrial animals breathe, comes from this particular blanket. So it is important. So while the temperature, regarding the temperature in the homosphere of stratosphere up to stratosphere, stratosphere spans up to you can say 10 kilometers. 10 kilometers and a little above, around 50 kilometers. And this, as you go from 0 to 50 kilometers, the temperature decreases. That is, on the ground level, it is warm. As you proceed from ground level to little top, vertically high, the temperature tends to decrease. That is the reason why when you fly in airplanes, everything is completely, reduced pressure, and you can't open the windows to the sky because it is freezing cold outside. So cold temperature is there outside in the beginning, from bottom to say up to around 50 kilometers. From there onwards, when you go to stratosphere, stratosphere starts from 50 kilometers to 150 kilometers. 100 kilometers is the blanket. Here, from 50 kilometers onwards, from the ground level, it was decreasing. From 50 to 150, the temperature increases. You see, first decreasing, and in the troposphere, you will have increase of temperature. And above 100 kilometers, when you start with what is called mesosphere, then the temperature again decreases. And above the mesosphere, in the ionosphere or thermosphere, infinitely temperature increases. So the drama is, as you go from ground level to the top ionosphere level, it will be decrease, increase, decrease and increase temperature. DI is the concept that you travel from ground level to the ionosphere, which is the highest space level kind of activity. And depending on the quality, depending on these levels, that is your tropo, meso, thermo spheres, the temperature gradients has a high significance for the turbulence and also for the mixing up of the pollutants. Now I said that at ground level it is warmer, and above up to 50 kilometers it is cooler. This is an extremely important condition for us because the warm gases, that is pollutants, that is spewed off, that is thrown out of exhaust fumes and chimneys of industries, they are warm in nature. So they will, because of the temperature gradients that is above the ground level, it is cool. This particular smoke that is in the gaseous form goes upwards, travels upwards, because upwards it is cool, downwards it is warm. So the gases are warm, so it wants to go so that it will lose the temperature, gets cooled till it becomes the temperature of the atmosphere. This is naturally happening, and this effect of moving upwards, the pollutants, the warm pollutants moving upwards from ground level is called as upwelling effect. UPWELLING, upwelling effect. And that is the reason why we are able to live, because the pollutants which are very bad in nature are thrown off. They are just rising above the ground level, above the nose level. So human beings are protected. The buildings are protected because they are continually going subjected to this upwelling effect and goes above and above, because upper strata or upper layers are cooler than the ground level strata. That is what is called, it is a very good boon that the nature has given us, that upward is cool, lower is warm, and all human activities are warmer in nature. Pollutants are warm in nature. So these warm entities which are bad in nature naturally gets diluted by the upwelling effect, so that we are not exposed to it and we are not inhaling it. That is the exactly what happens in the homosphere, that is very near 0 to 10 kilometers from the ground level to the upper air level. So this upwelling effect can be reversed if there is something false ceiling, that is the upwelling effect can be stopped if there is a false ceiling above the ground level near about 10 kilometers. And that happens, and if that happens in certain conditions called inversions, that the upwelling effect stops, the pollutants tends to rise, hit the false roof and come back to the ground level, when all the human beings they get exposed to a higher level of concentration, and we get episodic kind of bad effects or diseases. This happens generally in winter when the cold weather is there, when cold is damp as well as heavy. So that becomes a false roof above the ground level, and this upwelling effect gets completely ceased because of this visible kind of what is called false roof. And that is the reason why the fog formation, smog formation happens. Smog is nothing but smoke plus fog. That is a compound word. And this fog is so dangerous in winter. And that is the reason winter is very vulnerable, very dangerous for air pollution to occur. Is it not? You see, we read from newspapers that in winter in Delhi, the smog conditions create lot of haziness, poor visibility, heavy nature of gases, because human activities don't stop, vehicles doesn't stop moving. So the throwing of gases happens, but they are not subjected to upwelling effect for becoming diluted. And because the concentration suddenly surges during the daytime, the chronic inhalation of these pollutants results in lot of diseases. We need to be very, very careful. And this phenomena is also known as atmospheric inversion or temperature inversion. Otherwise, temperature should be cool. Because of the false roof created by the fog and smog, the upwelling effect stops, the warmth increases at the ground level, and the pollutant concentration gets accumulated, and this accumulated pollution concentration is inhaled, and we end up in a lot of coughing and respiratory problems. We have to be very, very cautious, especially in winters, not to have this kind of natural phenomena of upwelling effect stopping and getting into episodic dangers of air pollution. And that is the reason we need to be very, very cautious in winter. Winter is very dangerous, especially for young children and also aged people who are already weak in their respiratory health, and those people become vulnerable and at higher risk for air pollutants in the winter season. Now let me just show you how the structure is delineated. There is absolutely no real layer, but we can differentiate between the layers considering the heights. Troposphere 8 to 10 kilometers, stratosphere 10 to 50 kilometers above the ground level, meso 50 to 150 kilometers, thermo or ionosphere 150 to 400 kilometers. That in fact, this is what is the space. This is where your rockets, your other launching vehicles are placed above 400 to 600 kilometers. Homosphere, which is very near, that is a mix of tropo and strato. Mix of tropo and strato is where the human population is present, and that is also dangerous, very, very dangerous, because that is where every activity has got to be monitored, and we have to be careful. Because of inversions, the concentration of pollution can be more and even sometimes fatal. We will learn about that little later. Now, the same layers shown in a kind of picture form. You can see the picture here. You see, if you see the non-linear temperature on the x-axis, distance above the ground level on the y-axis, that is height on the y-axis, you see it starts from minus, that is zero level, 0 degrees centigrade, goes on decreasing till about 10 to 15 kilometers, then increases up to, for example, 80 kilometers, then again decreases up to 100 kilometers. From 100 kilometers onwards, the temperature goes on increasing. And the mountains which are ice-clad, icy mountains which are responsible for formation of rivers are present within 10 kilometers from the ground level. Because it is on the land itself. So troposphere is extremely important. Changes happening in the troposphere with respect to height and temperature is extremely important. And as you go upwards, it is always cooler. So you have, at the ground level, lot of heat generated, gets cooled, and then that currents come back to heating here, cooling there, heating here, cooling there. This particular cycle is making our life very, very easy, and also, we livable. But after about 15 kilometers, still around 80 kilometers, you have increase, a transitory phenomena, then decrease, another transitory phenomena, but going on increasing on unidirectionally, that happens in the thermo or ionosphere. This has got to be kept in mind. This is a very important aspect, and this is what that governs completely weather and meteorology. That itself is a very big science. very big science. And under the environmental studies, we need to learn this particular meteorology or climate, that is nothing but whatever that is default present as air, gases, the temperature, and also the so many other reactions and interreactions in interconversions that is happening on the ground in the space that is called atmosphere. Now, little bit about inversions. As I told you, inversion is nothing but the transitory fog or icy layer transcending or descending from the mountain top to the ground level. You see, on the ground level we have factories. It is because of the upwelling effect, the hot gases from the hot region to the cold region traverses naturally. There is a current because air current is there, and they go on getting diluted. They don't come to earth level, unless there is an artificial ceiling that is created here. If there is an artificial ceiling created here, then there is no upwelling effect. All the movement of the gases come down and affect us, and that is what is happening in atmospheric inversion concept. The temperature at ground level is 6.5 degrees. It is warmer than just 1 kilometer above the ground level. Since warm air is less dense, less weighing, it tends to rise, and that is called upwelling phenomena. Okay. The next, if the temperature at the surface becomes cooler for any reason, which is very dangerous, it should not become. Coolness should be always above the ground level. For some kind of reason, what is that reason? We will learn a little later. Then the denser, cooler air near the surface cannot rise. Upwelling stops, resulting in what is called atmospheric or temperature inversion. When upwelling stops, pollutants injected into the surface remains as it is because they are not diluted, and results in buildup or accumulation of concentration of pollutants, and that is what is called an episode. Episode can span from 1 hour to around 5 days to 6 days in a continuous manner, and during this short span of time, because there is a very surge of pollutants, all dangerous diseases sets in, and we get completely ill within very short time. So it is an acute episodal phenomena, right? Now we have to understand what is this smog. Smog is a complex word, hybrid word, forming between smoke and fog. Fog is that icy and watery layer which is in the vapor form, smog formation. Smoke itself is defined as the mixture of particle and gas. Many people do not know about this. If there is no particle in the gas, then it is not called smoke, right? Smoke is a mixture of particle and gas. We say cigarette smoke. That means in the cigarette gaseous mixture, we have a lot of particles, and that is the danger. There are about 3,000 pollutants just in one puff of cigarette smoke. So, very, very dangerous mixture. That is what is called smoke. Smoke is generally resulting from combustion processes. Combustion, that is, any article, any matter you burn, then smoke naturally comes. That is, two gases come out as pollutants, particle and gas. Particle is a primary pollutant, gas is a primary pollutant. When these two things are mixed and smoke is formed, smoke is a secondary pollutant. Particle in itself may not be that dangerous. Gas in itself, that may not be dangerous, but smoke is definitely dangerous. No? That is why secondary pollutants, I have told you yesterday that it is very dangerous. Now, this compound smoke, which is a mixture of gas and particle, is a secondary pollutant, and that gets mixed up, especially in winter season, in cold regions, and the fog of the ice, so the particles and gas of the smoke combine together to form an aerosol, which is called smog. And this concentration, if it increases in the environment, two very bad effects happen. One, because of the many pollutants that is present, that is gas, particle, and also water droplets, that is fog. This reduces the environmental temperature, increases the risk of respiratory infection. And finally, the smog is the reason for temperature inversion. Smog formation is the reason for this particular phenomena that has to happen. It is a dangerous pollutant. Another area where smog is very commonly encountered is the oceans. Oceans also in the cold season get highly cool, and air traversing above this cold air, vast amount of air in oceans also can be form smog in those areas wherever there are cold, Pacific, Atlantic. They are all very, very cold oceans, and large amount of land areas also get converted into smog, and there the life becomes extremely, extremely important. So two vulnerable places, mountainous area and also cold shores of oceans, are very, very regions where smog is formed. And smog reduces the visibility. Not only accidents happen very much, but also the pollutant accumulation happens. That is the importance of temperature inversion. Now, what are the ideal conditions? I have already told you. There is a mountain. You can see I have put a mountain picture here. There is, see, always on the top, there is no habitation because it is uninhabitable. Nobody can live there. It is icy, sub-zero. Sometimes it can go up to -60, -70 degrees centigrade. So nothing, no life is possible there. Human life is not possible there. Human life is possible in the down, that is on the ground. It is called valley. That is from top to bottom. It is valley. The ice that is formed as a cap or completely covered mountains, the ice slips down and becomes a false roof. You see this particular hazy area above, there is a clear sky above the mountain. This is clear, but here it is hazy because the ice sheet has fallen down and has completely locked up as a false roof to the valley. And in the valley, we are traveling, we are having industries, and pollution, which otherwise in other seasons has to go up, will not go up because this particular false roof, as the smog has formed, prevents the pollutants to get dispersed. You see, dispersed. This particular smog and the activities falls roof for a temporary phenomena. When the temperature is conducive, when the temperature are getting inverted, because of the sun presence, even though sun's presence is there, that warmth will not be transmitted to earth. It is trapped in the smog region. It is trapped in the smog region. So you have a lot of pollutants in the smog. There is heating source by the sun. So these very dangerous chemical reaction happen in this smog, and all carcinogen compounds that are formed because of presence of hydrocarbons, presence of so many number of pollutants and heat, and also the water vapor inside the smog itself is very, very ideal for forming dangerous carcinogenic chemicals, carcinogenic pollutants. So primary pollutants become secondary pollutants, and these secondary pollutants are accumulated on the ground level, and all human beings get subjected to a lot of bad effects within a very small time till the smog clears, right? So it can happen in one day, it can happen in few hours, it can happen in 5-6 days, and many incidents, the reports are there during that short time of smog and temperature inversion phenomena. Many people even have died. Many people have taken a lot of respiratory diseases. You see, the ideal conditions to form the temperature inversion or atmospheric inversion is nothing but clean ocean air, which is cool, blowing on the surface of the earth, cloudless, clear sky. Sky is always clear, but below the cloud there is always haziness because of the smog formation, and mountain range and the winter season. These are the 4 important preconditions for what is happening for the phenomena atmospheric or temperature inversions. Cool ocean air, cloudless clear sky, mountain range, and also the shore, cold oceans, and winter season, all are very good for the smog formation and inversions to happen. You see here, mountain range, clear sky, mountain has given the foggy layer slip down on the city. You can see the complete haze. Whole city actions are happening in the road. Otherwise, if it is not there, the pollutant should have gone and diluted. Now, because of the smog, all that, haziness, increased number of accidents, increased accumulation of pollutants is affecting the habitation. Similarly, cold air from the sea come and become, a hazy layer, which is called smog. And smog, reduces the visibility, increases the number of accidents. And this is what is happening in formation of temperature zones, in formation of what is called, smog. You see, pollutants have to rise continuously, but it is stopped because of the false haziness. This one, because cold air from the sea has come, affected building, affected habitation, and photochemical smog is formed because sunlight converts many pollutants, primary pollutants, into secondary pollutants, and we are getting as secondary pollutants very dangerous and health effect resulting. Temperature inversions happen at a very large scale, especially in some areas, and that is the reason why we need to be very cautious during winter. Now, because of this phenomena, in the history, what are those bad effects that has happened during kind of winter? You see, I have just listed some 6 or 7 episodes. They are episodic. Episode is nothing but short-lived, but very dangerous time, where acute effects happen. Acute is nothing but high concentration for a short time. We have defined it yesterday. So there is Meuse Valley, mountainous valley in Belgium in 1930. Because of the conditions of inversion, smoke, sulfur dioxide, hydrosulfuric acid or sulfuric acid, 60 excess deaths, within matter of 2-3 days, thousands getting ill, eye and nasal irritation and cough. That were the symptoms. This is the gist of a scientific study that I am just projecting for you to understand how episodes of air pollution become dangerous for many people within short time, becoming a issue. Again, you observe it, especially the period, they are all winters except one episode. There is everything is in winter, December, October. In USA, this is another valley, inversion and fog, sulfur dioxide, smoke particles, they are the responsible pollutants that accumulated. 20 excess deaths were recorded, 6,000 of towns of 14,000, almost nearly 50% of the population became ill, irritation of nose, eyes, respiratory tract, breathlessness, and vomiting sensation because of that particular smoggy condition. The recorded, episode. Again, in Mexico, a place called Poza Rica, 1952 November, winter, a shallow inversion happened because of fog and calm conditions. Hydrogen sulfide was released due to a burner failure of a factory. 22 excess deaths happened, 320 hospitalized. Irritation of the respiratory tract happened in a single day. That is in 1952. That is also because of the haze, because of the smog. London, very famous episode in the history of temperature inversions, which shook the complete England, in the place London. Again, December 1952 winter, very low temperature inversion, thick fog, stagnant air, movement was not possible, upwelling was completely stopped, smoke and sulfur dioxide accumulated because of routine traffic activity, transport activity, mobility, industrial activity. 4,000 deaths within a matter of 5 days. Thousands hospitalized for respiratory and heart diseases and chronic bronchitis, that is asthma. That was a famous episode that happened, which made every scientist, every environmental scientist very cautious to do a lot of in-depth researches, and that is now we have some kind of clues how to prevent formation of these smog on temperature inversions. That is a tragic accident that happened in London in 1952. Again, you see a winter season, January, London, second repeat happened. 1,000 excess deaths happened because of another repeat episode in London. Third episode in 1962, again December, winter, 700 excess deaths, increased illness happened. Winter of 1966 in New York, 168 new deaths, that is sudden deaths. This is in the summer season. This is the only some kind of little exception. Seveso, Italy, because of the industrial accident, a dioxin formed. Dioxin is nothing but secondary pollutant forming in the environment. Cloud settled over the area of a very big area, and although deaths were not there, the health conditions prevailed. It's an industrial activity, industrial disaster. And of course, in India, we have witnessed again in winter, Bhopal gas tragedy, which made everybody to become very cautious. Release of so many tons of deadly gas, methyl isocyanide. Death estimated is 2,500, but it could be more. 1 lakh population, 1 lakh. Please remember, 100,000 people got completely lot of diseases and irreversible damage. Many people died. That is again happening in winter, accelerated by smog formation, so that it did not got diluted. Everybody had to inhale these poisonous gases and subjected to lot of discomfort and loss of life. That is the list of episodes that we need to remember because of air pollutants, and also known as a peculiar unique phenomena known as what is called temperature inversions. Now we move on to the 10th basic concept, and that is called, criteria or index pollutants. Now what is this? As all of you know, we listed about 200 chemicals that is human manufactured or human invented chemicals. They are all potential pollutants, right? Depending upon the quality and quantity of these nature, very vast number of pollutants, it is extremely difficult for us to say, suppose this, wherever that you are now viewing this, we are listening to my lecture, if I say, whether your area, wherever you are living, is polluted or not, if I ask you, how will you answer? Because 200,000 chemicals is a possibility. They are all thrown in the environmental media, that is air. It is possible some will be more, some will be less in quantity, but there is a variety of thousands of chemicals that are possibility in the environment. If I ask you, your environment is good or bad, it becomes extremely difficult for us to isolatedly or individually monitor these n number, I should say infinite number of pollutants, and then promulgate my pollution, my environment is clean or unclean. So it is difficult for anybody to kind of say what is the quality of environment you live, whether it is clean or bad. You should always say it is unclean because we have not monitored. There could be some pollutants which are unseen, where there are particles which cannot be seen by eye, but they are potentially dangerous, we can't say. So for this difficulty, if we want to proclaim a particular area is polluted or not, the scientists of the complete the universe joined together and indicated there are listed some 6 pollutants, 6 common pollutants, which are nothing but generally the combustion products, that is wherever you burn the fuel, combustion products, but they must be common and they should be monitored. And if the concentration of these 6 pollutants you are trying to tell, And all these 6 common pollutants have a threshold limit value. And if they cross the threshold limit value, you can say that particular environment is polluted. So for the ease of identifying or categorizing a region into polluted or not polluted, the concept of criteria air pollutants was necessitated. Index is nothing but index finger. Then you can say this area is polluted because I have found one of these are all the 6 of listed accepted air pollutants are higher in concentration than what the level the scientists have prescribed, which is called threshold limit value. And that is the concept of criteria pollutants. Criteria means it is the criteria if the threshold limit value is more, that particular region where you have monitored that particular gas is a polluted area. It is extremely important because urban areas are polluted. In urban area, majestic area is more polluted. You know that we have to delineate a particular area to put some control measures, is it not? So recognizing, as evaluating, and then controlling are the 3 sequential steps in managing the air pollution. So recognition is okay, quality. Evaluation is you have to sample and do a chemical analysis, and what pollutant is there you should understand, and what pollutant in which level it is there you should evaluate, and then put a control measure. For this purpose, 6 common pollutants have been listed. 6 common pollutants are listed, and these common pollutants are, it starts from carbon monoxide. Okay, you can start anywhere, but it is 6. Carbon monoxide, ground level ozone. Actually, it is because ground level is the starting point. We call this as 1, this is 2, this is 3, this is 4, this is 5, and this is 6. The sequence is not important, but the quality of this listing is very important. 6 common pollutants known as index pollutants. When you monitor one or all of these, you are speaking the area pollution, wherever that you have monitored, that particular region's pollution you are talking about. And that is very, very important for us to, put some control measures and also learn about the quality of the environment that exists. So that is the reason why we have 6 criteria pollutants. This is categorized by what is known as an agency called EPA, Environmental Protection Agency, which is the American agency, and many countries, more than 170 countries have accepted that these pollutants, yes, if they are present, we can say that particular region is polluted. So EPA has defined these criteria pollutants, and that is the reason why these pollutants are continuously monitored to understand the level of pollution every moment, every minute, every hour, every 24 hours day, every year, because air is an entity where you cannot stop breathing, is it not? Whether it is night, whether you are sleeping, whether you are active, air has to be breathed, and these pollutants have to be present in the air itself. So the expression of the pollution is, for example, lead is milligram per meter cube. Meter cube is in 1000 liters. How many milligrams of lead is present? In 1000 liters, how many milligram or microgram or nanogram of carbon monoxide is present? How much of milligram per meter cube? How much of particulate matter milligram per meter cube? Meter cube is 1000 liters. Sulfur dioxide also. All these 6 pollutants have what is called threshold limit values, which is safe. That threshold limit value is nothing but the standard limit, but that is not the standard for the same level for everything. Depending on the nature of the pollutant also, those standards differ, but normal levels are prescribed. And once that normal level is maintained, fair enough. Within that normal level, fair enough, pollution is not there of that region. But if it crosses, then there is a danger for health. That is the usefulness of having criteria pollutants. So ground level oxygen, particulate matter, carbon monoxide, lead, sulfur dioxide, and oxides of nitrogen, they are very, very common, everywhere encountered in all regions of the earth. That is the reason why they are considered as index air pollutants, criteria air pollutants. Suppose tomorrow you want to study, you will put up a project of air pollution, you will have to choose 1 or 2 or everything, all the 6. for your measurement, and then go ahead in delineating that particular environment is clean or unclean, polluted or unpolluted. That is the concept of what is called criteria air pollutants. In the next about half an hour or 1 hour, we will try to understand each of these pollutants, because they are very, very important. In fact, that is the only thing that air pollution comprises of as in environmental studies. These are class common, highly dangerous air pollutants. We learn about them little bit in the forthcoming slides. But as of now, there are 2 more concepts, and after those 2 more concepts, we go one by one. What is the source and what is the health effect of these pollutants individually. So this is Environmental Protection Agency, which has set what is called National Ambient Air Quality Standards. They're nothing but a standard is that level which is safe. Safe level is already prescribed. Safe level, by doing intensive research over many years, they have put up these levels. For example, ground level ozone, it is ppm is nothing but milligram per meter cube, mg by 1000 liters. In 1000 liters, 0.07 gram should be present, or 0.07 milligram should be present in 1000 liters. That is a very low level. In ground level, ozone is a pollutant, whereas in stratosphere, ozone is a protective layer. That we will talk when we deal the ozone individually. Particulate matter, that is the technical name, but generally it is known as dust. Especially suspended particulate matter. Suspended means what? That which is not settleable. The mean mass particle diameter and size is very small, 10 millimeter diameter, very small diameter, and if that is there, the 12 microgram per meter cube, 1 milligram is 1000 micrograms. So you see 1000 micrograms, such a small quantity is the threshold limit value for one type of 10 millimeter diameter of particles. For 2.5, which is little finer particles, it is 20 microgram per meter cube. They are not to be seen by eye, but this is what is called threshold limit value, which is a safe value. If you go beyond this, there is a danger. If you are below this, there is safety. That is what is the meaning of these particular threshold limit values, or National Ambient Air Quality Standards. Ambient means atmosphere, air is air, a mixture of gases. Quality is that particular, whether it is PM, CO, or that nature, quality pollutants, and standard is that particular safe level. National is at the national level. All the 50 states in United States of America has proposed this particular level. And they have to maintain, the government has to maintain these levels for the health of the public health reasons. So national ambient air qualities are set by Environmental Protection Agency of United States of America, and there are 6 pollutants delineated, listed to be those pollutants which speak of pollution of the area, and they are common. They harm health, they harm environment, and they harm the property also. That is the reason why this index air pollutant and study of them becomes extremely important. EPA itself was established in 1963. Clean Air Act was established in 1970. You see, this particular act is promulgated. That means it has become a law now. That means these levels have become a law. That means if there is higher concentration than this, that particular source or whosoever is producing that level will be punished by the act. That is the meaning of regulation. So these levels also become guides, or where you can take punitive or actionable limits. Only 3 times this particular, since last almost 50 years, only 3 times amendments have been done. That means it is a very robust act, very strict act that is being followed in the United States. Similarly, we also have in India, and we talk about it little later. The last but one basic concept as TLV, we know a little bit now, we have already talked. Regulatory agencies are those inspecting agencies which have power to prosecute, power to punish. They are central pollution control boards, state pollution control boards, that's the name in India. Environmental Protection Agency is the name in United States. Similarly, in some other countries, the names will differ, but the philosophy is same. The concept is same. Regulatory agencies are those inspecting agencies which have powers to punish if the levels are crossed, right? There is another parallel environment. This is for general environment, public health, and this is for occupational environment inside industries. Inside industries, the levels of also are fixed by an agency called American Conference of Governmental Industrial Hygienists. American Conference of Governmental Industrial Hygienists. This comes under the ambit of Labor Ministry or Industry Ministry in our India, and inside the industries, inside the occupation, also the workers are getting exposed to that particular manufacturing product, and that environment, because those people have to live 8 hours a day, 40 hours a work week, it is extremely important. They should not get disease because they are the productive force, and their health has to be maintained, and it is the duty of the employer of that particular university to maintain those levels. If that is not maintained, this labor ministry takes punitive action or takes out even license of that particular factory. So this is occupational environment, this is general or public environment, and corresponding levels are always prescribed, both in India and USA I am putting, but there are many other names in many other countries, little altered names are there, but philosophy is same. There are different kinds. Let me just spend about 2 to 3 minutes about explaining to you what does this threshold limit value means. The word threshold limit value, whenever you use, it is the property of always the United States of America. ACGH has given the pollutant level as threshold limit value. We can't use in India, but the concept is so common that we tend to use that. But we in India use what is called ambient air quality standards, not NAAQ. N, if you add, it becomes American. You see, in N, that is ambient air quality standards, national ambient air quality standards for America, just ambient air quality standards for India. Threshold limit value, property of occupational environment of ACGH of USA, because it requires large amount of time and money to establish standards. This American Conference of Government and Industrial Hygienists, though government is there, it is a non-governmental agency, purely a research agency, which time to time, every year, goes on updating threshold limit values for pollutants. As of now, there are about 150 chemical threshold limit values are set in. Very common industrial chemicals, threshold limit values are available. Now, what is this TLV, TWA as prescribed by American Conference of Governmental Industrial Hygienists? This is nothing but that concentration during 8 hours of a work shift, the concentration in that particular occupational environment should not increase. That is the standard safe level. So that is called time weighted average. See, in industries, depending on the particular process, sometimes the dust clouds are generated, sometimes the cloud becomes less. During the 8 hours, there are cycles of operations that can happen in industries, but it is an average level. For 8 hours, the concentration should not increase for the health, safekeeping of the health of the occupational environment and employees. So it is called threshold limit value. First category of threshold limit value, time weighted average, it is for 8 hours. Now there is another category called threshold limit value short term exposure limit, STEL values. Now what is the short term? Short term is 15 minutes in 4 spells during 8 hours. This is for complete 8 hours. 15 minutes that concentration can increase, but it is only for up to 15 minutes, not completely more than 15 minutes, and 4 times that particular level can increase. So threshold limit value can increase for a small spell of 15 minutes 4 times during the 8 hour shift work, and that category is known as threshold limit value short term exposure limit. That means they're allowing a bit higher levels in the air occupational environment, but the time is fixed for 15 minutes in one spell, right? So that is For some operations it is needed, so they have defined stale values. There is third category, yet another category, threshold limit value, ceiling limit. That means this ceiling means at no point in time during 8 hours the level should go to ceiling. It should not exceed. So that limit also is prescribed. One is 8 hours, 15 minutes, no time. At any point in time, the level should not increase. It is a level, but that level is a reference level. You cannot increase to that level, ceiling limit. So one particular chemical, for example, say fluoride, or for example, ammonia, for example, sulfur dioxide, can have all the three levels. It can have average level, it can have 15-minute level, it can have ceiling level also. We need to understand, and it is a wonderful concept which is making which is by continuous research they have deduced these values, and they are the standards. They are the threshold limit value standards for air pollutants. Similarly, Indian scenario also is there. We did not do research, but we have adopted American little bit, tweaked and adopted. So ours is in adopted values from America. America gives free of cost to any country. So it is a non-governmental agency. It gives you the levels to follow. It is up to you. It is, if you follow it, it is good. If you don't follow it, we are not worried. That kind of a situation. But because it consumes very huge amount of scientific research and machinery, time and money, we have adopted the values what is prescribed by American standards, little bit Indianized, little bit tweaked for some pollutants. And we call that as, we can't use the word national ambient air quality. We have to have our own word. It is ambient air quality standards, which our Central Pollution Control Board at the central government level prescribes for all the states at State Pollution Control Board to, monitor, to inspect, to give do some kind of what is called policing activity. Ambient air quality standards are there. And in India, we call threshold limit value as PEL. It is not TLV. TLV we can't call it as, because it is a trade name of American Conference of Governmental Industrial Hygienists. We are calling it as permissible exposure limits. That is from the occupational environment. We call them as permissible exposure limit values. They are same or almost little bit relaxed, but it is, the philosophy is same. We, instead of TLV in India, we call as permissible exposure limit values or limits in India, promulgated by Labor Ministry. These standards has to be maintained very strictly in the occupational environments. This ACGH is general environment. This is occupational environment. They have got to be very well maintained. Otherwise, there is a kind of fine. There is a kind of punishment. Punishment can also mean the complete, taking away license of manufacturing industry itself, or pollution creating source itself. This is, in summary, what is the account of what is called threshold limit values. They are the guidelines. They are very, very important for any study. They are the source values for comparison. Now, there are two words we need to remember. If you have to delineate the levels, we have to sample the air and also subject it to chemical analysis to find out what is the concentration and compare with these standards, that is, or these charts that are present, these listed charts that are present. So that particular random sampling at any point, either the general environment or occupational environment, is known as air sampling. Prescribed methods are always there. You have to follow that method, sample the air, find out whether you are in the safe limit or not, just like how we measure blood pressure levels, right? Sampling. Now, monitoring is a word where continuous sampling has to happen, because air pollutants are generally prescribed as that particular mass, that is microgram, milligram, divided by 1000 liters of air. So 1000 liters of air is fixed, but the time is also fixed. It should be continuously 24 hours all through the year. Right? Monitoring is a continuous sampling and analysis. Generally, it's a continuous activity. So a particular machine operates all around 24 years, day and night, and gives an average value for a complete year. That is what is called ambient air quality standard. Ambient air quality standards are always annual averages being conducted 24 hours representing all the seasons of the year, 1 year. So that is the difference between sampling. Sampling is only to check as a test random. Monitoring is checking seriously whether we are complying to that particular prescribed standard. Both are very, very important. Both are important. Now, for doing this, 3 steps are extremely important. First, we should know what is the kind of pollution, whether it's sulfur dioxide or carbon monoxide. We should know quality wise. That's called recognition, because we know the chemistry of that particular features of that particular pollutant. Then we have to quantify by sampling. Sample, then analysis is called evaluation or assessment. That particular decides whether we are within the limits or above the limits. Then we can engineer what is called control measures. Control measures, minimizing measures. If it is more, what control measure has to be put. So this particular environment studies, ladies and gentlemen, you should remember, is an ocean, and it is a thrilling field of study. A serious study where you can yourself engage and make a big career, either as an appraisal scientist or an evaluation scientist or a control engineer. You can do any kind of work. But what is that business in that particular? It is very clearly, explicitly defined. Appraisal, assessment, abatement, in this sequence only. You can't do randomly. First, you should know what is quality wise, what pollutant you are sampling, what is the amount of that particular pollutant, compare to the chart, then put a control. This is how the air pollution exercise, air pollution studies becomes continuously ongoing for many kinds of pollutants. And as of now, we have very less number of standards. It has got to be increased year on year. It is increasing, and as of now, we have about 500 pollutants, both occupational as well as general pollutants, whose levels are listed by American Conference of Governmental Industrial Hygienists. There is an exhaustive list. You can refer, you can put ACJH in the Google, you will get that particular list and get to know what pollutant, which level that is prescribed, so that you will be speaking scientifically of that pollution level of that particular area. So it is just to remember, we call it as 3As or REC. 3As refer to appraisal, assessment, abatement. REC refers to recognition, evaluation, and control. Now we come to the last concept in the series of concepts. This is the last concept. Now we know that the level of pollutants in the environment, but what is the problem? The level of pollutant, if it is the environment, it gives you a warning signal. Not all this concentration that is, so that means we have talked about quality or health of the environment. Now, if you want to talk the health of the individual, this particular air or concentration of pollutant outside your body has to enter in. I told the portal entry is the nose. Portal entry is either inhalation, ingestion, or skin absorption. 3 routes for the human body. And this particular picture, you please very closely follow. When we say respiration, when we say lung itself is a system made up of many parts. It has nasal cavity, starting with nose. It has oral cavity, because all gas that is inhaled through nose has to go through what is called pharynx. Pharyngitis, if there is some problem, pharyngitis will come here. This is a very important area where either 2 routes are possible. One route for, there is epiglottis here, a flap. The flap gets closed if it is food and water, so that it is directed to stomach. The flap opens if it is air. Air is let in. Other than air, everything is going out. The whole system is caged in what is called a vacuum system. The respiration occurs inside the lung in a vacuum area, but air is inside. Air is inside, where gas exchange becomes extremely important. So if a particle size is 7 to 10 microns, microns is micrometers. Micrometer is 1000 micrometers is equal to 1 millimeter. 1 millimeter itself is small, is it not? But you see, 7 to 10 micrometers, that is So 7 microns, 10 microns, very small size particle. 5 to 7 is still smaller particles. This, that is 5 to 10 micron size, is trapped inside this oral cavity, which is the white space that I have put. Traps here. Traps itself. That means compare it to 1 to 2 microns or even sub-micron size up to 0.5 to 1 here. This is bigger particles. They are trapped in the upper regions of the respiratory tract. The upper regions are nose, oral cavity. Sinuses are also there. Nasal cavity, sinuses, and oral cavity. Then there is a tube, very hard trachea tube, cartilaginous type of very hard tracheal tube. But if it has to come here, the size should be little lesser than this, 3 to 5. That is within 5 microns, it comes here. Then it goes to left lung and right lung, which is a tracheole. Left lung and right lung, they end up in what is called alveoli. They end up in what is called bronchiole. Bronchiole is the terminal sac, very thin sac, membranous sac, where gas exchange is possible. And this particular whole, this is tubular system, conduited. It is simply like just water of a water supply of a urban area or a town. The air supply happens to all the alveoli, and alveoli are engaged in what is called air exchanges. But if a particle has to come up to alveoli stage, that is the lowermost respiratory tract area, the particle size should be very, very small, 0.5 to 1. But this is safer because this can be reversed. Whatever that happens up to here, black level, 3 to 5, they are safe because you can cough and then reversible things in the cough, the particles that are settled can come out. There is a possibility of reversible action, and that particular disease where the reversible action is possible is called upper respiratory tract infections. That is, in the upper regions, the infections have happened. That is not very dangerous. It is reversible. You can come back to normal health. So bigger particles, if you inhale, not much difficulty, but it can also be a nuisance value, but you can come back to normal level. You can come back to normal level. But the danger is if the level or the size of the particle is lesser than 5, 2 to 3, 1.5 or even submicron, then there is a come and go into the lower tract. And once it goes to lower tract and finally it gets settled in alveoli, that alveoli is gone. It is defunct. You can't, because it becomes fibrosed. It becomes stiff. Muscles become stiff. There is no pumping. There is no, kind of air exchange that is possible. Peristaltic movement is not possible. So what happens, the alveoli gets completely destroyed. And that is why the vital functions like vital capacity, the air inhalation, air exhalation, it should be free. The cavities should be free. They cannot be clogged with these particles. If they are clogged with the particles, your complete vital capacity itself comes down. Well, there is a reserve, but your normal function is reduced, and air exchange, when it is reduced, oxygen absorption becomes reduced, and you get into a lot of series of chain diseases. This is the importance of respiratory tract anatomy. Size dependent, lower respiratory, upper respiratory reversible, lower respiratory irreversible. If there is a blockage that is possible, whole defunct or the complete non-functionality of the lung is possible, and that is the reason why we have got to be very, very careful when we know that there are very small particles, aerosols, and we have got to be guarded. They should not be left at all inside the respiratory system, so that you will be very efficient in breathing. That is the end of what is called basic concept treatise. Now, little bit more, we talked about individual pollution. I'm not talking in depth, but it is good for us to understand, because these 6 are accepted by scientific world are the common pollutants, criteria pollutants. It is good for us to know where they come from, what are the special features, properties of these danger pollutants, and how they can be prevented. What are the diseases or the effects that comes? So little bit of what is called appraisal, little bit of features, little bit of what is called effects or health effects or environmental effects they cause. We try to list and learn, list and learn. One by one we go. We start with what is called ground level ozone. Ground level ozone. First one is ground level ozone. We try to understand. You see, ozone is a very interesting story. We have ozone layer, very thick layer between the junction of tropo and mesosphere above the in the atmosphere. First and second layer of the atmosphere, we have a ozone layer. Why that ozone layer is there? It is default present. As it is present, it is doing us a great favor of filtering the bad ionizing ultraviolet radiation of the sun, solar radiation. If that there is no ozone layer, the sun directly or the ultraviolet radiation directly comes to hits the ground, and ultraviolet radiation is ionizing in nature. They go and hit the DNA of the cells, and DNA gets damaged, broken. It is like an X-ray, you know, it is like a bullet. The bullet means what? It shatters the complete, the very property of DNA, and it converts that DNA into disrupted codes, and lot of serious diseases happen. So this particular radiation is being cut off, is being screened by the protective ozone layer, default as it is present at the junction of tropo and mesosphere. You know, that is extremely important. So it is protective in nature in the space, whereas ozone is also formed at the ground level. There is a secondary pollutant. We have at the ground level oxygen. For some variety of reasons, variety of conditions, which we learn little later, this O2 can become O3 at the ground level. Please understand, ozone is a very strong, oxygen itself is reactive, and O3 is highly reactive, highly reactive. And once ozone in trace levels that is formed at the ground level, then it is a pollutant. You know, it is a very, very serious pollutant. Because of the reactivity, it can convert many things into oxidized form. Oxidation means burning, ashing. No, completely ashing activity can happen, right? So we have to be guarded. Ozone at the troposphere level is protective. Ozone at the ground level is dangerous. So it has danger and also safety together. And ozone, by the way, as a gas, is fishy smelling. Oxygen is not smelling, but ozone is having a very strong fish smell. You know, you should understand. And it can kill anything that comes in. That is the reason why ozone sometimes we use in killing bacteria in water, like, you know, replacing bleaching powder, replacing the chloramines, which are used as disinfectants in water treatment. Ozone is also to some extent a very strong oxidizing agent. It decimates, burns off all the pathogenic bacteria in the air. But if it is used usefully, it is useful. But as it is in generally, when it is formed as a secondary pollutant in the ground level, it is extremely dangerous. Extremely dangerous. It has that combustion power. It is very, very dangerous pollutant. That is the reason why it is put in the first as criteria pollutant, ozone. And this is pictorially, this I have taken from the Environmental Protection Agency. I wish you please visit this particular site. Whatever that I explained from now onwards, I have taken from Environmental Protection Agency site, from the government of USA. Okay, so you have sun continuously burning. There is no sleep for the sun. All of you know, sleep is only for human beings, but sun is always there in the environment. And sun's good rays are good, but bad rays are also, you know, very dangerous. One of the component of sun bad rays is ultraviolet rays, and they have got to be cut off. So at the troposphere level, this ozone layer takes care of that. But at the ground level, because of this chimney gases, because of the exhaust gases from the vehicles and industries, emissions, and also presence of oxides of nitrogen, because oxides of nitrogen also coming out of exhaust gases. Volatile organic compounds, that is hydrocarbons, n number present in the environment because of the unburnt fuel. Heat and sunlight from the sun become deadly reactants, and ozone is formed at the ground level. Ozone is formed. Ozone is the result of these reactants. It forms. This particular ozone at the ground level is a very dangerous pollutant. So this is bad portion of it. The good portion of it little later we learn, but this is what is bad. Criteria level 1. So we have a threshold limit value prescribed for ozone, that is 0.07 microgram of ozone per 1,000 liters. That is such a small quantity that itself is very, very dangerous. Another point you should remember is, if there is 1 milligram and 0.07, 0.07 is 700 times or 700 times dangerous, 700 times dangerous. So sub-decimal places, they are dangerous. If the threshold limit value is 0. and onwards, it is more dangerous. But if it is 5 milligrams, it is less dangerous. That is another way that you can say, classify the potential danger associated with pollutants. So this is formed in the now this is a good ozone layer that is already present here. You see, just after troposphere and the first portion of the stratosphere, in the junction, which is a protective layer, and we have very bad chemicals, very persistent chemicals called volatile. These are all anthropogenic in nature, man-made. Chlorofluorohydrocarbons, volatile organic compounds. We have n number of freons, refrigerants. Those are the chemicals. They have high power of upwelling, going and cutting or hitting the ozone and thinning the ozone level. Once a ozone hole is formed, then ultraviolet radiation of the sun directly reaches the earth, and lot of cancers, lot of dangerous effects, harmful UV rays which are ionizing in radiation happens. So that is protection layer. This is the danger layer. Here it is protection. On the earth it is danger. That is the speciality of the ozone in environment as an index pollutant. It can be good depending where it is found, whether it is on the earth or whether it is on the troposphere. If it is in troposphere, we should protect it. If it is in ground level, we should avoid it. That is the philosophy. That is the spirit. In stratosphere zone, it is good ozone, naturally upper, protecting from ultraviolet rays, bad effect of ultraviolet rays, right? And this beneficial zone has been partially destroyed because of human-made chemicals, very potentially dangerous, not convertible so easily. They have pervaded, they will react with ozone, and ozone itself is consumed, and ozone hole that is formed, which is an imminent danger. So we should be very, very highly cautious about the very strong pollutant ozone, air pollutant ozone. Now, what are the health effects? The health effects are listed here. You see, people most at risk are people who are already having some kind of asthma, bronchitis, children and older adults, people who are active outdoors. They are highly vulnerable or highly risky to get exposed to ground level ozone, which is a secondary pollutant. People with certain genetic characteristics, syndromes we call them, they are also vulnerable. People with reduced intake of nutrients, some people cannot digest or cannot have a mechanism to metabolize vitamin C and E, they cannot digest, they are very dangerous. For them, ozone affects little more, they are at a greater risk. Breathing zone can trigger, in the breathing zone, that is just ozone at very proximity of your nose, it can create your chest pain, coughing, throat irritation, airway inflammation. Inflammation is a expansion, artificial expansion, and it is painful. And also it can reduce the vital function, lung function or lung capacity, vital capacity of exchange of gases, and it is harmful to the lung tissue. This is the list of ozone bad health effects that it can cause. It can worsen the already existing preconditions like asthma, Now, what is the environmental effects of ozone? What is to the health of environment? This does bad. Ozone affects sensitive vegetation. That is, agricultural yield is reduced. It is poisoning ecosystems because of the high reactivity. Conversions, interconversions are possible. Bad compounds are formed in the ecosystems. It is on a massive scale very dangerous for forests. There is a condition called what is called chlorosis, that is chlorophyll formation is inhibited. Photosynthesis, if it is inhibited, the food formation is inhibited. It destroys the aesthetic level beauty of parks because it is a burning agent, you should understand. And it also has a bad effect on wildlife. When it has effect on human life, naturally, on wildlife also, it has a bad effect. So on environmental scale, it is bad. That the ground level ozone is very, very bad. Ground level ozone harms sensitive vegetation during growing season, cutting the yield. So from the environment portion, also the ground level pollutant is dangerous. The second criteria pollutant is interesting, and this is regarding particulates, or in common language it is called dust. Dust is a local language. We should not call as environmental scientists dust, but for ease of understanding, you can call it as that. But the correct technical word for particulates is SPM, suspended particulate matter, or TSP, total suspended particles in the environment. Suspension means what? That which can stay, that which can, governed by what is called colloidal movement, Brownian movement. Because of the small particles size, they can get suspended, continuously moving around in the blanket or in the solvent medium of the air, that is in the space. That is what is called suspended particulate matter. Dust has a capacity of settling on surfaces. They are all not that dangerous from the point of health. However, they have nuisance value. What you can see, the dust particle is not that dangerous, but what you inhale, what it goes inside the body, that mass and diameter becomes critical. The deposition of particles in different regions of the respiratory system depends on the size. It is technically known as, the size is average diameter, mean mass, diameter. Mass also is critical because it has got to get floated in the environment, suspended in the environment, so it should be less. Size should be small, that is diameter should be small. So it is called MMD, mean mass diameter is the correct technical size of the particle. That is, we should be worried of as environmental scientists. Large particles deposited in the nasal region. I have to show you that the respiratory tract anatomy, you should understand the size. Bigger the size, it gets trapped in sinus, lateral sinus, frontal sinus, trachea, pharynx and larynx, and also some portion of trachea. That is large particles which can be expectorated, which can be removed by coughing. Smaller particles goes down to the lower trachea and bronchioli, and they are dangerous because they stay there and exert lot of bad influence and reduces the vital capacity. So dust size is determinant, where it is deposited is determinant, mean mass diameter is determinant, suspension nature is dangerous, settleable nature, though it is little less dangerous, but it is having nuisance value. All those things we need to remember when we talk about the criteria pollutant number 2, that is particulate. Now this chart is important because this will tell you, depending on the size and also some other toxic properties, poisonous properties, what are the types of particles, how many types of particles are there. They are all in particulate form, right? Particle is nothing but discrete, solid forms, right? Let us just list out these very bad particle sizes as well as some toxic properties. One is called, as I told you, SPM or TSP, suspended particulate matter, total suspended particulate matter, generally above 25 microns. That means anything below 25 microns cannot settle. Anything below 25 matters always gets suspended. anything above 25 microns, which is total suspended particles, includes the dust that is settled as well as suspended particles. Respirable particles, that which can be inhaled, that is 7 microns and below. It can be submicron also, 7 to even 0.5. We have seen in the respiratory tract infection. Third variety, third type is what is called viable. Viable means, the word viable means living, that which can reproduce, but in particulate form. Pollen grains, fungi, spores, molds, bacteria, they are microorganisms. They are viable. They are also solid in nature. They can also be very easily inhaled because they are lesser than 7 micron size. Viable particles. Non-viable particles, aerosols, we call them as aerosols, like organic particles, pesticide cloud, smog, they are all non-viable. They cannot reproduce, but they have bad components. Mineral dust, mineral component of the particulate form is dangerous because coal, silica, cement, asbestos, they are very, very dangerous. Particles can be ranging from submicron, that is inhalable, to 100 or over 100 microns. They can be settled as dust. They can be inhaled also. They produce a lot of diseases. Especially, this is the greatest problem in occupational environment. Coal has to be mined, stretches miles and miles of coal mines. Millions and millions of coal workers, they get exposed during coal mining, and they, over a period of time, they get a disease called pneumoconiosis. Pneumo, P-N-E-U-M-O-C-O-N-I-O, coniosis, S-I-S. Pneumoconiosis is a class of lung diseases that coal miners get. Silicosis is a disease that people with silica, granite quarrying, cement manufacturing, that operations, silicosis. Cement is an element which is both lot of metals are present. At least there are 16 components of elements in cement. It is a complex mixture. Asbestos, fibrous form, they are very small, very dangerous. They cause what is called mesothelioma, pneumoconic diseases, and then asbestosis. They are occupational in origin, mineral dusts, nuisance dusts, which are very big in size, but at a higher dose, they can cause respiratory problems, especially of higher or upper respiratory diseases. They are of nuisance value. They may not create serious health problems like mineral dust, but they have problems. Calcium carbonate, alumina, emery, starch, zinc oxide, they are all present in the layers of earth as rocks. We powder them and use it in chemistry and chemical applications. That is of nuisance value. Last but one is vegetable dust of vegetable origin, coir fibers, cotton fibers, tea particles, jute fibers. They are of vegetable origin, but they can be particulate in nature. Toxic, very poisonous, highly dangerous to some system of human body. Cadmium, I told you yesterday, kidney cortex, kidney problems. Lead, very dangerous. We talk about lead in detail. Mercury, very dangerous. We saw that even zero amount or less amount of mercury causes negative health effect. Nickel, causing nickel cancer. They are very, very dangerous, but they are industrially highly useful. So we have to handle them, but with caution. Environmental, occupational environment or environmental scientist takes care of such studies, finds out which is the safe level and warns the people. That is what is about criteria, pollutants, dust. The other small left out is effects of pollution, effects of this dust pollution. You see, it is injury to respiratory system. I need not explain. Weakening of resistance to infection, which is very dangerous. You're open for that. Your immune power gets down. Immune power or fighting power for the diseases goes down. Synergistic effect is nothing but combined effect. That is, if sulfur dioxide alone has a pollutant effect, suspended particulate matter, that is dust, has a separate effect. If suspended particulate matter is a absorbing surface, because it is solid, the sulfur dioxide can go get absorbed in the pores of the surface of the particle. Such a sulfur dioxide laden dust particle, if it is inhaled, you get a condition called synergistic or potentiation phenomena. This is a very important phenomena. Now, this is combined effect, not just of SO2 SPM. It is like, if this is 1, this is 1, it is not 2. It is exponential. It is 11 actually. And that 11 is now known as synergistic effect. Alone, okay. Combined form, very dangerous, most dangerous. That is what is called potentiation. Lead is a very big poison. We talk about it because it is a criteria pollutant. We talk about it little later. The third pollutant is carbon monoxide. Carbon monoxide, that is very dangerous. Many people know carbon dioxide. In fact, everybody are bothered about is only this particular carbon dioxide and carbon monoxide. They are formed in the environment, especially because the engines have, throws out carbon monoxide as an unburned portion of the fossil fuel. Unburned portion, because our internal combustion engines are not efficient. 100% burning is not possible. So incomplete combustion leaves carbon monoxide outside. If it is full, it is carbon dioxide. That is also a pollutant, but it is not a criteria pollutant. But carbon monoxide is more dangerous when compared to carbon dioxide. Both oxides are formed depending on the combustible power, and especially in the urban environment, which is anthropogenic made. That is the reason why carbon monoxide is very, very dangerous, and that is how it is generated. Especially in chimneys, when you burn the fuels, either oil or gas, you get carbon monoxide as a pollutant, as an emission. It is introduced by human activity. It's product of incomplete combustion. Incomplete combustion comes out as an exhaust, either as a stack emission of an industry or a exhaust emission from a crankcase or from an engine. It is the single largest component, that in the urban atmosphere. Very characteristic to urban environment, because urban environment is characterized by lot of vehicular pollution as per convenience of traffic. It is formed in urban smoke. So carbon dioxide, carbon monoxide particles, they combine together, they become synergistic in nature. Danger increases. Exhaust fumes of burning fuel. It is colorless in nature, so the danger, we can't see it. It is odorless gas, so it can't be seen, it can't be smelled. But most dangerous property of carbon monoxide is that it is heavier in air. Naturally, when hot airs are there, if they are light in nature, they can go. Upwelling effect is possible. As I told you, natural upwelling effect we have seen in inversions. But because it is heavier in nature, carbon monoxide stays at the nose level during in the traffic, at the nose level, because of its heavy nature. It is heavier than air, so it remains at the ground levels for a longer time. And carbon monoxide, therefore, is a dangerous pollutant. But highly common in environment. It is because of this property, heavy nature of the carbon monoxide. Now, the effects, it is a very strong ligand. It is proton donor, so it can form compounds, and it will poison the hemoglobin, which is responsible for oxygenation. Oxygenation is because of hemoglobin. So hemoglobin is really completely converted into carboxyhemoglobin, and when carboxyhemoglobin forms, blood is poisoned. Just like cyanide, cyan-methemoglobin forms. Here carboxyhemoglobin forms, and once carboxyhemoglobin is formed, that cannot be excreted. Air exchange is not possible. Cleaning is not possible. It can only result in death. So carbon monoxide on a long-term exposure causes dangerous deaths, and it is a dangerous asphyxiant. It chokes It will completely prevent your oxygen to act, oxygen goodness to act. So it is a dangerous asphyxiant. Asphyxiant means throttling, making you breathless. So poisoning the blood, making you breathless. These are the two dangerous properties or biological effects of carbon monoxide. Next, I will stop after this. The rest of the things we will talk in the next class. Lead is a very funny metal, highly stable metal, highly dense metal, and lead is so docile, so inert. It is opposite to ozone. It is not at all reactive. However, lead is a very useful metal for industrially, right? Lead is as it is present in the environment in some traces. So lead also is available in the form of in the molten condition. It can be vaporized in industries when you make lead acid batteries. You know, the cathode that is formed is casted. So lead has to be, you know, melted, and during melting, overheating is possible. Lead can be vaporized. So in vapor form it is available, in particulate form is available, in also dust form, that is lead is powdered, and this powder is coated on the discs that is casted in the cathode of batteries. So lead dust is possible. Because it is available in all the three forms, dust, gas, as well as, you know, the liquid form. It can be liquid, that is molten form. Lead is very dangerous. Now, what are the sources? As it is present in the atmosphere. Nobody can prevent it. Lead tetraethyl, lead tetramethyl, we intentionally add as additives to prevent anti-knocking property of the internal combustion engine. They are additives. It is now banned, but in some countries even now they are cheap, so they are adding it. Automobiles have lot of lead emanation because many parts of automobiles are even solder, welding joints. That sometimes lead is there. Smelting operations. Smelting is nothing but alloying operations. From the ore, when you extract the metal, you get the lead leaked out. Coal has integrally present, lead is present integrally. When you burn the coal, when you ash the coal for energy purpose, lead is emanated. Refining of lead scrap, you know, to recover the lead because it is precious material, they recover the lead. So when you melt the lead scrap, the possibility of emanation into the environment is there, possibility of liberation is there. And of course, lead acid batteries are still in use. Lead acid batteries are potential dangerous occupational environment for lead as a source for the environment. Please understand, lead is so dangerous. Initially, it was not known. When Romans were there, lead glasses were used. You see the green tinge. If you see in a glass, that means it's a leaded glass. Leaded glass. You have glasses. You have even alloy, lead alloy, and lead adds very taste to the wine. You see when wine drinkers used to take in lead cups, so that sweetness of wine is increased, but that is dangerous. Over a period of time, they get poisoned. So many deaths have occurred because of consumption of some drink, consumption of some liquids using leaded vessels. Lead is extremely dangerous. Now, what are the effects? It can be uptaken by skin, uptaken by lung. It can be inhaled. Blood, when it goes to the blood, this anemia results because it can block the heme synthesis. Heme is the red pigment of your blood that can be completely stopped. So anemia results. Soft tissue, it can be absorbed and stored and affects what is called reproductive system. In fact, the WHO as of now is so much worried about the lead that the quality of human sperms are decreasing, and many mental retardation cases, because lead has neurotoxic effect, mental retardation cases are increasing in the incidence and prevalence, and because of the lead. So lead is a scary substance. very commonly present but highly dangerous. It can, when it is ingested, when it is eaten, it produces unbearable what is called colon pain, colic, lead colic, very, very, dangerous and unbearable stomach pain. It is neurotoxic. It has not left nervous system. Unfortunately, the lead from the mother can go to offspring by the cord blood, umbilical cord, which is nutrient conduit. So the boy or girl or the offspring that comes out of the womb can have mental retardation at the birth level itself. Females are very susceptible, highly susceptible females. In fact, there is a new law now that in battery industries, females cannot be employed because of the reproductive age, vulnerability, and also unique susceptibility of female population to lead that is promulgated. And bone, finally the lead goes and settles, replaces the calcium of the bone, and the bone itself becomes the source, so that when you become aged, that leaching is possible to the other compartments, and lead poisoning finally results, which is called plumbism. And once plumbism sets in, it is the nothing but a reflection of death. There is no other way to come back. There is no other way to come back. So lead is such a dangerous metal. You see, loss of libido, infertility, blood pressure, aggressiveness, loss of appetite, constipation, and colon, lead colic, anemia, severe cases, paralysis, that is neurotoxicity, fits, swelling of the brain, seizure, coma, neurotox. So it has not left any system. It is liver poison, it is kidney poison, it is respiratory poison, it is blood poison, it is CNS, central nervous system poison. So lead has corrupted everything, and that is the reason why lead is considered as a criteria air pollutant. One has to be guarded about lead, especially the vulnerable population, and also children and females are very, very vulnerable for lead poisoning. Next time we talk about sulfur dioxide. I will stop at this today. We have 2 or 3 more small concepts, small treatise to be told. I can cover that in next 10 minutes of the next class. I will stop at this today, and please, again, I reiterate, all of you should ask several questions. I expect at least 15 to 20 questions. It will be collected by Professor Shubha and Professor Abhijit. They will give me, I will answer in the last of next session, which I will complete, and the first unit will be completed by next 15 minutes which I will postpone it to the next session. I will stop at this today. I think the time now is almost nearing to 11. We have little exceeded, but it is fine. But there is 15 minutes more that is left out, that I will talk in the next class. Thank you very much for your patient listening. Please make a lot of questions. It is questions that I like very much, because I will understand how much my lecture has been useful to you. And by asking questions, you also learn a lot. Please put up all the questions, make the list of questions passed on to Professor Shubha and also Abhijit, so that I can collect them and answer in the next session. Next session, only 1 hour I will talk, half an hour I will dedicate to interaction. Thank you very much and have a nice day.
Thank you, sir. Abhijit.
Abhijit, yeah, thank you.
Sir. Thank you, sir.
Thank you. Shall I close it, Abhijit?
Yes, sir. Sure, sir.
Thank you.